Okay, welcome to the stage, our second guest, Dr. Lace Padilla. Welcome.
Thank you so much for having me.
Of course. Okay, so as a bio, Dr. Lace Padilla is an assistant professor of computer science and psychology at Northeastern University. Her interests lie in the intersection between information visualization, behavioral decision-making, and data science. Her research is on uncertainty communication, which explores how to align data visualizations of future events with human decision-making capabilities. That sounds pretty badass if I say so myself.
Quite a mouthful.
Yeah, exactly. Bless you. Okay, so when it comes to uncertainty, you are applying uncertainty in kind of like the weather space, or correct me, like where are you applying uncertainty in?
Sure. Oftentimes when people think about uncertainty, it can be really challenging for them to understand which context to apply them to. So we think about uncertainty in cases big and small. Uncertainty might mean trying to figure out if your transit route is going to be on time. That's a small decision, but it also can be big decisions like evacuating from hurricanes, deciding which medical treatment to undergo, deciding whether you want to invest in a stock market, for example. These are all cases with uncertainty, and people have difficulty reasoning with uncertainty, which is what we like to study.
Yeah. So I think when it comes to science communication, I think uncertainty always is like the biggest thing, because as scientists we're always like, well, this is just a probability. And so what do you think is the biggest gap between scientists trying to kind of talk about uncertainty around their research versus like the public wanting to know and have more certainty in the things that they're doing?
Yes, there's a big disconnect. Oftentimes as scientists, we want to be transparent and clear, and part of that is communicating the uncertainty in our findings. But there's a disconnect between what we want to communicate and what we think people can understand. Mm-hmm. We often assume that the general public is averse to uncertainty, and they might find it confusing and might even find it making them believe our science less. They make it more skeptical about our science. Mm-hmm. So what I'm going to talk about in my lecture is part of some of those misconceptions about how people reason with uncertainty, and give us some alternative ways to visualize uncertainty, which is what I actually study, that are easier for the general public to understand.
And then, just so you guys know, her talk is called Seeing the Unknown, Advanced Techniques for Communicating Uncertainty Data, which is today, later at 1 p.m. in room 311. I wish I can go there, but I'm going to be like living my severed life if you guys are watching Apple TV Severed. I'm living my indie life right now. But yeah, I think can you share with us at least maybe like one or two of the misconceptions that we can look forward to in your talk?
I think most people in here who have engaged in science have probably communicated the uncertainty in your data in things like confidence intervals, 95% confidence intervals. If you go to my talk, I will describe why that is one of the most challenging ways for people to reason with uncertainty, and give you some alternative ways to visualize your data that is easier for people to understand. What happens is when we have continuous data, which is what uncertainty is, and we show it in an interval of a 95% interval, all of a sudden it makes people switch from thinking about distributions to thinking about categories. And the 95% confidence interval is very peculiar because the category isn't that meaningful. So we do 95%, but we could do 94% or 96% or 22%. And the edge of that specific interval makes people think that data inside the interval is more likely than outside, which is a huge misnomer. So we have some alternative visualization techniques that I'll talk about, and some caveats as well.
Yeah, when we think about data viz, so when I was in grad school and I worked in a chemistry lab, I was lucky enough to have like a mentor that kind of talked to us about, as we were writing our paper, she taught us to like think about the figures first. Yes. And so, but the figures that we make in our papers doesn't always translate when that gets disseminated into like the public information sphere. So I guess like how do you think about your figures to also kind of accommodate, like if someone that's not reading or someone that's not in our technical field and is going to use this to put in like a science magazine, like how can we better?
Okay, so the problem with thinking about figures is they're often taken out of context. And among the things that happens is that people focus more on the figures sometimes than other aspects of your paper. It's usually the thing that they'll put up, in the blog article, the figure. So The tricky part is ensuring that that figure accurately illustrates all the nuance in the science. And it often can't because you're simplifying things down to different relationships. So there's a whole art in terms of creating figures that accurately reflect your science. And I think that it is really crazy that we have all this training to conduct the science, to write up the science, and almost no training on how to visualize the data. And that can sometimes be the most important part, the thing that outlasts, not outlasts the paper, but sometimes the thing that people focus more on is the figure. So I don't have a solution for you, but it's a shame.
Yeah. I guess, like, what do you think is the common pitfall in, like, designing figures, or aside from, like, the way that we demonstrate uncertainty in our figures, but I guess, like, what are other things that kind of, like, make it hard to read, our figures hard to read?
I think that the way that everyone, if you have no training in visualization design, the way that you make figures is the way that you've seen them done in papers previously, the way that you were shown in your stats class or by your mentor to do that. Okay. And so there's this historical legacy for how we represent data that is not backed at all in the science of how people reason with this information. So I think the biggest pitfall is thinking that your figure needs to match all of the papers that you've seen in the past. And what I would encourage you to do is to make figures that you think tell the story of your data as honestly and accurately as possible. And sometimes that means not using the techniques that you commonly see in your field. Sometimes that means adding a little bit more narrative to the figures. Sometimes people are uncomfortable about that in science. So don't feel compelled to make your figure look like previous papers just so it gets in. As scientists, we should want to clearly and effectively communicate our data to the best of our ability.
How would you describe good data visualization?
I think good data visualization makes things, it kind of reveals the true nature of the data clearly and accurately. As we know, most of what we're representing is so complex you can't show everything. So taking the major messages and revealing them in the data is what I'd call a good visualization. And one of the amazing things about visualization is our visual system, which is our eye-brain connection, is very good at pattern recognition. So if you capitalize on one of our very strongly evolved capacities as humans to communicate information, then you have to do a lot less work in terms of describing and kind of detailing things. You're letting the visual system express your data, which is the power of visualizations.
Yeah. I guess what can we look for, or what other things can we look forward towards in your lecture later on?
So I'll talk a lot about data visualizations, but I'll talk about many real-world applications. So I've done work in situations like looking at COVID-19 visualizations, hurricane forecasting visualizations, and more common ones that we see in terms of science papers like confidence intervals, that type of thing.
What type of tools? Are you okay? Yeah.
I thought I dropped my phone. I didn't. Okay.
I guess, yeah. What are kind of like the best tips or best practices that we can go towards in our data viz?
Oftentimes people do think about tools, in part because the tools tend to define what we do. If you have a software that you input your data, sometimes it gives you a default visualization and you may or may not go with that. But I would say any software or tool to visualize data can do different types of visualizations, and there's such a diverse audience, I'm not going to recommend a specific tool, but if you learn some basic principles, you can apply it to any different tool that you have available.
When did you start thinking about like data viz? That's just kind of like, okay, this is my thing. This is what I want to like, it's a little bit more of like a passion in advocating or at least, representing data visualization.
Yeah. So I actually have a background in art. My undergraduate degree is in art, and I have a master's degree in art in addition to my PhD in cognitive neuroscience.
Amazing.
Yeah, and I was always really impacted by the power of visual information. As an artist, I was really compelled to try to understand why a painting affects us or why a movie is so profoundly impactful. And I took that passion and I thought, well, why don't I do that to actually make positive change in the world? So I switched to data visualizations because I can look at situations like evacuating from hurricanes or communicating COVID-19 and use my interest in visualizations to try to help people become healthier and safer in society.
How did you make that jump going from art into data? Like, I feel like, man, like if you're just in the art world, I'd rather stay in the art world.
Yeah, people always think it's a jump. I think it's very, very similar. My skills that I used in art are very applicable to my life as a scientist. And I think it was always the same thread, the same passion. I went from studying it in an artistic sense to exploring it scientifically. So it's very linear for me, but I understand how people can see it as a jump.
No, also, that was kind of like lame of me because, yeah, data, like science is art and vice versa, as someone who is going to always advocate for science communication. Okay, as we wrap this up, I do want to bring up the fact that you have a YouTube channel, and you actually share data viz tips on our YouTube channel, as well as kind of like navigating graduate school. For those who are interested, you can follow her at Dr. Data Viz, like VIS. Yeah, what got you interested in wanting to like start YouTube to talk about data viz?
A lot of different things. So I've always had a passion for helping people get involved in science. Part of the reason I wasn't a scientist initially is I didn't know any scientists, when I was in high school and in my early years. And I thought the only way to be involved with my passion was to go into the arts field. I think I would have always studied visualization if I had known it was a field. So among the things I like to do in my YouTube channel is to show people the path to getting into graduate school and becoming a scientist. There is a very clear path, unlike other disciplines, I suppose. And had I known that path initially, I would have taken it. So I'm very compelled to help people understand what that path is on a large scale. So everyone can be a scientist if they so choose. And en route, I also try to do visualization education on that channel as a little bit of a bait and switch, because I do think it is surprising that we get all of this training to communicate in words our science and not as much in terms of visuals. So when people are beginning their academic journey, I try to serve them up videos about communicating visually their data in hopes to kind of make the visualization literacy stronger in science communication.
Yeah, are there any resources that people can look into to kind of like get better training, better practice in data viz?
You can go to my YouTube channel.
Nice,
the fun part is there's a ton of materials online. It would depend on your specific field, because what tends to happen is people get routed into different visualization programs. So based on a particular field, I could give you a recommendation for the program that would be most relevant to you. On my YouTube channel, I have a visualization theory feed. So it applies to anyone across different disciplines. Yeah, I don't have any more recommendations.
Yeah, okay, so just a reminder for those that want to see her main lecture today at 1 p.m. in room 311 called Seeing the Unknown, Advanced Techniques for Communicating Uncertainty in Data. But thank you, Lace Padilla.